guys, I am going to do the last part of this worksheet. So let's start with number 4. This is where we left off. It says calculate how many grams of iron are made from 16.5 grams of Fe2O3. So I am looking for grams of iron. They are giving me 16.5 grams of Fe2O3. All right, so grams to grams, once again, a 3-step problem. So I'm going to write down what they give me. I have to put grams on bottom to cancel out through division. Anytime, if you've not noticed, anytime you're dealing with grams, it's always 1 mole. Now 2 irons and 3 oxygens weigh 160. So right now those have canceled out. Now I'm going to do moles of Fe2O3. It has to go on the bottom so they can cancel through division. I want iron, so I'm going to use mole to mole. I'm going to use my equation 2 and 1. And then the last step, moles of Fe have to go on bottom so they can cancel out. I just need to know how much does iron weigh. Now it's not Fe2 or anything like that, like we get O2. It's just iron, so that is 56 grams in 1 mole. 16.5 divided by 160 times 2 times 56 is 11.55 grams of iron. All right, let's look at number 5. It is telling me that I have 28.6 grams of iodine chloride. It's kind of a weird one there. One we don't see too often. Anyways, I got 28.6 grams. They want to know grams of just iodine by itself. So once again, a 3-step problem. So I'm going to kind of walk through this pretty quickly. I'm going to do the capital I there so it doesn't look like LCL. It is ICL. When you weigh this thing, it is 162.5 when you add all their weights up. Remember, always 1 mole. Now this is where I do my mole to mole. And I'm going to switch over to my question mark, what I'm looking for. Use your equation in this step. 2 moles of iodine, 5 moles of ICL, moles of iodine on bottom, grams of iodine. Iodine weighs 254 in 1. So you're going to take 28.6 divided by 162.5, multiply by 2, divide by 5, multiply by 254. Now you don't have to go in that order that I tell you. You could, I don't know, multiply by 2 right first thing, and then multiply by 254, then go back and do all your division. It does not matter. You will get the same thing. Your answer should be 17.88 grams of iodine. All right. Let's look at number 6. How many moles and how many grams of potassium permanganate are needed to carry out this reaction on 11.4 grams of KNO3? So once again, if I'm going from grams to moles, that is a 2-step problem. If I'm going from grams of potassium nitrate to moles of potassium nitrate, that is 1. But this is moles of something new, so it's going to be a 2-step problem. So let's do that one first. So I need to know how much does potassium nitrate weigh, and that is 85 grams for KNO3. And that's always in 1 mole. Now let's do my mole to mole so I can switch over. Now anytime I have a mole to mole, I am using the equation. So if I look up here, there's 2. And my KNO3, nope, not that one. KNO3 is 5 also anyway. So if I were to solve for this, 11.4 divided by 85 times 2 divided by 5, this is 0.05 moles. That answers this question here. Then it says how many grams. So you could do this, and then you could go down and rewrite this entire thing, the 11.4. You could rewrite this and this, but I'm not. I'm going to go ahead and just do it one step to get my grams. So I'm going to put 1 mole, okay, MnO4, and now grams. When you add all of those up, that is 158. So here's answer 1. My answer 2 is going to be how many grams? And that is 7.9 grams of potassium permanganate. So there's answer 1, here's answer 2. And like I said, you could, if you wanted, if you feel more comfortable just rewriting the whole thing out and doing 3 steps at once, that is up to you, but you can just do that. Saves you a little time. Number 7 is the exact same way. They want moles and grams of oxygen. They give you ammonia though, so you have 56.8 grams of this, and we want grams and moles of my oxygen. So 56.8 grams of ammonia. Put grams of ammonia down here. NH3 weighs 17. So let's do our mole to mole. Moles of NH3 on bottom so we can cancel out through division. I want oxygen. There are 5 moles of oxygen and NH3 is 4. Once again, I'm getting this from my equation. This will give me moles of oxygen. So 56.8 divided by 17 times 5 divided by 4 is 4.176 moles of O2. Now to get grams, I'm going to do that last step. Put moles of O2 on bottom. Anytime you're dealing with grams, it's always going to be 1. Oxygen weighs 32, not 16. This is O2, weighs 32. So this is 133.6 grams of O2. So here's answer 1 right here. Here's answer 2. All right, and now for the last one. It is the same type of thing. They are giving us 16.4 grams of NaIO3, 16.4 grams. Now they want the number of moles and grams of iodine. So I'm going to take that 16.4. I need to figure out how much that all weighs. Sodium, iodine, 3 oxygen. That is 198 grams. Always in 1 mole. Now let's do my mole to mole. Once again, my mole to mole, I'm getting my numbers from up here, so it's going to be 1. I'm trying to get to iodine, so that is 3. 16.4 divided by 198 times 3 is going to be 0.248 moles of iodine. Let's do that last step to get to grams. Iodine weighs 254 grams. So 0.248 times 254, that is 62.992. You can round, I'm not picky on the rounding, I don't care. Grams of iodine. So anyways, guys, this is pretty much what we will be doing in section 3 and section 4. So we need to make sure we have this down. This is the last participation grade for section 1 and 2. You now are going to get a grade that, or a worksheet that is for an actual grade. So please let me know if there's anything that you need help with. All right, bye.